Greetings from EPG Pathshala. In this module we are going to talk about web security. There would be no one who is not using web nowadays. What are the threats when you are using web that would be included in this module? I would be covering the client side threats, server side threats, how these threats can be mitigated. Web works on many layers of OSI. So at each layer, what are the threats, that also we will see in this module. The major thing starts at the application layer, and when you go up to the physical layer, at which layer what informations are added, that is the part of my talk today. First, the key term is web threat. Web threat is the threat which is done via World Wide Web and which compromises authenticity, integrity, confidentiality, non-repudiation and availability. Keep in mind, when we are talking about security, there are 5 parameters that need not to be compromised. Once again I will repeat: authenticity, integrity, confidentiality, non-repudiation and availability. Web threats are divided into 2 major threats: push threats and pull threats. How push and pull are distinguished? They are based on their delivery method. Push based threats, they try to collect information or inject malware. How? By sending spam or by phishing or by other fraudulent means. What does a phishing mean? If somebody sends you a mail saying that you have got a patch from Microsoft, but they spell Microsoft as not MI but M1. If you are in a hurry, you will not check whether it is MI or M1 and you will click on that link, and what happens, it goes to the fraudulent site, some malware is loaded on your machine and then your machine goes off. So this is kind of phishing attack affects the computer and it is called push based attack. Another push based attack can be materialized by DNS poisoning. DNS poisoning means you think that the data has come from a trusted authority, but actually it has come from some fraudulent source. Pull based web threats, they are majorly driven by downloads. So when you try to download something, the cyber criminals give the malware to that link, you will download that malware, and when the page is loaded, the user's browser passively runs a script, a malware downloader runs a hidden HTML frame without the user's information, and then the user's machine goes down. So at each layer, first we will start with application HTTP client. What are the dangers there? It's a cross-site scripting attacks. All this I will go into the detail, but just to give an overview, application HTTP client, it's a cross-site scripting attack. Unpatched web clients, transport layer HTTPs, they have man in the middle and session hijacking dangers. Firewalls allow HTTPS, that is a secure layer. Web server has a threat of repudiation, information disclosure, elevation of privileges, denial of service. Web application scripts has buffer overflow problem, firewall has internal network, database has SQL injection danger. Website vulnerabilities, there are major 5 vulnerabilities: website defacement, buffer overflows, // application code errors and server side include. Website defacement, website code is downloadable, If you go to the source, attacker can see the full hypertext. Attacker can also view the commands in the code. This is called website defacement. The second website vulnerability is buffer overflow problem. So for that there are 4 cases to be considered. How buffer flow problem occurs, that we will see first, and then we will evaluate what 4 cases of buffer overflow can affect our system. So for that we have written a for loop. That for loop starts with index equal to 0, index less than or equal to 4, index plus plus, buffer space I equal to x, and what I have done is buffer space 5 equal to z. Actually we used a buffer space array which goes from 0 to 4 only, but we try to write at a space 5. So it goes out of the buffer. So let's check what happens. So when we try to write at the position 5, it may interfere the user's data. If it affects the user's data, the data would be changed. The second case occur, it may add to the user's program code. So Z is written in the user's program code area, so that would change the instructions which user has written. The third case occur in the case of buffer overflow. When we try to write Z, it may interfere in the system's data, so it would change the system's data to give a unexpected output. The fourth case is if we are trying to write the Z as a buffer overflow problem, it may interfere the system program code. So what it would do? It would paralyze the instructions of a system program, and system program would behave in an unexpected manner. So what we have observed is buffer overflow problem. In that case, the overwriting can be done in the user's data area, user's code area, system's data area, and system's code area. The next website vulnerability is ... indicates predecessor directory, and ... is the grandparent of the current location. So check the URL in my slide, URL return, so that server returns the file autoexe.nt. Once that file is written, the attacker can perform modification or deletion. http site.com, and you can check the URL where we have written ... So every time it will go to the grandparent directory, and it would try to fetch autoexe.nt. Next is application code errors. User's browser reply to the server with full context. User can modify the context. Check the URL. In that we have got I1 equal to 459012, P1 equal to 139, I2. So full URL is retrieved. What an attacker will do, for the P1 139, it can change to 199, or it may change 1199 with 1399. So now 2 books only cost 398 instead of 2598. Server side include, it says this type of code opens a telnet session saying that exec command is equal to user bin telnet, and it is supposed to be the comment, but now this type of code opens a telnet session, and attacker may execute commands such as chmod. Chmod command can change the permissions on the remote machine. Next is we are talking about client level threats. There are two types of threats: cross-site scripting and unpatched web client. Cross-site scripting attack, where attacker is trying to inject HTML data into web content. Attacker is trying to trick the user into visiting the XSS vulnerable site. Now this injected HTML data executes on the user's browser and again invokes an unexpected behavior. The second client level threat, as we talked, is unpatched web client, patching desktop software like web browsers so that security requirements are met. We will take an example of cross-site scripting, where I would be showing a simple JSP page in which we have written a Java code inside the HTML. It starts with HTML tag, body, a simple text called hello, and then we have added a scripting saying that out.println welcome. Welcome by getting the parameter through URL. So request.get parameter and name. This will get a parameter value name when you run this test.jsp. Then Ahmedabad, body tag ended and HTML tag ended. This simple JSP script you have to run in a browser with the help of server. So if you try to pass the script saying http localhost and then the test.jsp, passing the parameter name equal to LDCE, it would simply print a welcome LDCE message. But now the trick is, instead of passing simple string, what we are passing is a script tag saying name equal to script, then alert saying that hello, and then script tag ends. What has happened now, we have passed a script in a parameter, so when you run this program in a browser, it pops up an alert saying hello. This was a simple hello message, hello alert printing script, but an attacker can write a more malicious behaving script, and if they can append this script as a parameter in URL, your system again would get an unexpected behavior. What are the countermeasures against cross-site scripting? Educate users. The first is educate for the threat of cross-site scripting. View web contents only from the trusted users. Then the next step is implement browser security. Nowadays browser also comes up with lot many security saying that disable the use of JavaScript or active scripting for untrusted zones such as internet zone. Moral: you need to disable the running of JavaScript to protect your computer against cross-site scripting. Countermeasures, if we go ahead, the second is educate developers. Up till now we educated the users, now educate the developers to validate all input that could potentially be used as a part of dynamically generated web responses. So in the example we checked that for the parameter the user can only enter string, but we never checked that user cannot enter script tag. So that is where the developer has to learn to validate the inputs in terms of what it is going to produce when given to the browser. The next is encode URL. URL encoding normally performed to convert data because such data has a special characters such as slash, dot, hash. These characters have a special meaning or is not a valid character for a URL. Then comes HTML encoding. and then it says use inner text property. So if I go ahead with the example of encode URL, you can check we have a simple form HTML form tag in which method is equal to get, action is equal to example.html. It says when a submit button is pressed, the URL should be invoked, that is example.html, and the method used is get. So parameter passed would be part of the URL. We passed parameter called name. This is a simple and short test. So if you check how the URL is formed, this plus is plus a plus simple plus %26 plus short plus test. Observation is all spaces are replaced by plus and ampersand is replaced by %26. This is called URL encoding. When I talked about countermeasures, I also talked of HTML encoding. Now, what is HTML encoding? So, if you observe a simple HTML code, what we have is angle bracket HTML, then closing angle bracket body, and then closing angle bracket hello, then the corresponding tags are close /body and /HTML. So, instead of angle bracket in the encoded HTML, we are going to write ampersand LT semicolon, HTML ampersand GT yani greater than sign and semicolon. In the body tag also, instead of angle bracket, we have written ampersand LT semicolon body ampersand GT semicolon. This type of encoding helps to protect from attacker who attempt to view code while the code is passing. Then for the countermeasures, I focused on inner text property. So HTMLs have two properties, inner text and inner HTML. The suggestion is use inner text property instead of inner HTML. Inner text property renders content safe and unexecutable. Inner HTML property is used to programmatically modify the contents within the opening and closing tags of the HTML server. An inner text property automatically encodes the special characters to and from HTML entities. For example, if we want to make a text bold, my text, to make it bold, we have a HTML tag called B. HTML tags are always written between angle brackets to end the tag /B. Angle brackets will not be recognized by browser if you are using inner HTML, but in case of inner text, it will be encoded as starting angle bracket as ampersand LT and semicolon and closing angle bracket as ampersand GT and semicolon respectively, and they are decoded by the browser later on at the time of display. Now we have seen client side threats, we will look at the server side threats. Web server threats, the first is repudiation. Repudiation yani we cannot deny the fact that this activities occurred on server. For that, log all activities to determine how the attacker intruded in the system. The second is information disclosure, server header exposure and directory browsing. Third is elevation of privileges, in which unpatched web servers, unknown vulnerabilities, non-essential services and canonicalization attacks are taken care of. The term is new for you is canonicalization attacks. So once again look at the URL, how it is formed: http test site /cmd %252 exe. What can we make out of this URL? Cape dot is replaced by %252e. If the security is on non-canonicalization forms of input data, attackers might be able to bypass some security features. So what is canonicalization attack? Clear. Then comes denial of service attack, where an attacker tries to attack on the system in such a way that the victim system is not able to reply. When I talked about web server threats, I talked about information disclosure. The first disclosure is all about server header exposure. If you know telnet, what does a telnet do? It tries to connect to the remote machine. So telnet needs to be given two parameters: the address of the remote machine and the port to which you want to connect. So we'll try to run a command saying telnet www.ldc.edu and the port number is 80. Then we will write head/http/1.0 saying that reply me the HTTP header for the version 1. So what it replies? 400, saying that bad request, but it still replies that content type is text/HTML, date and connection close, and content length retrieved for this header response is 34. So if connection would have been open, you could have logged in into the system. So this is how you can gain the information about the remote machine. Information disclosure, if we go ahead, the next point was directory browsing. Directory browsing is all about using a web browser, try to load a website or virtual directory. Directory browsing is enabled or disabled, that we need to check. So navigate to some directory saying http test site and test home. Check the response. How a server behaves: if that particular directory is not there, it would list all the directories in the default directory. So all the names would be revealed, okay, what this directory contains, if the given path is not available. Now comes threats in active or mobile code. What is active and mobile code? It is a code that is pushed to the client for execution. So there are 4 cookies, scripts, auto-exes by type and bots. Bots are the pieces of malicious code which can be controlled remotely. Network of bots is called botnet. The problem is of privacy on web. A user can visit websites, send messages or feedbacks, interact on web without revealing its identity, which is called anonymity. Cookies, adware, spy bots, malicious code can trap the identity. So let's check how cookies, adware, spy bots and malicious code can trap the identity. Let's see how the online environment works. So if you are making payments on the web, they are usually made by credit card or by online payment systems such as PayPal. For that, only site or portal registration is needed. Registration is often done through email. Email is usually related to your real name, so email and real name can be linked to other databases. There are third party advertisements, contests and offers which you would like to take. In turn, you give your data. When we talk about privacy, we said we can keep track of the users through certain mechanisms. The first mechanism is cookie. A cookie is nothing but a text file that is stored on the user's computer and passed by user's browser to the website when the user goes to that site. So, summarize, that cookie is nothing but a text file which is having 6 fields: name, value, expiration date, path on the server to which it is to be delivered, domain of the server to which it is to be delivered, SSL, that is secure connection required for delivering cookies. So, cookie has these 6 fields. A site can set any number of cookies. Cookies can be any in number, but the size limit is 4096 bytes. Some sites store cookies that contain user ID and password, so that customer does not have to remember their login. Some browsers ask you whether you want to store the password. If you say yes, they would be stored as part of the cookies. So, cookies can have a credit card number, customer name, shipping address, last time visited date, number of items purchased. If you have stored sensitive data as a part of cookie, it is in a plain text form. An attacker can easily read it and use the information. So, solution is, when you are using cookies, store them in an encrypted form so that your data is protected. Once again, if we want to monitor the user's activity, we can do it by third party cookies. These cookies are stored for organization other than web page owner. Third party cookies can count the number of times the browser has viewed the particular page. The second is, it can keep a history of visited page. The third, it can count that how many times this advertisement appeared on the page. It can match the purchase with the advertisement displayed on the page. So, third party cookies usually are used to observe the customer behavior. Then comes web bugs. Web bugs are invisible image. They are usually very small. They are also called clear image. They are 1x1 GIF. 1x1 is just like a pixel image. It is too small to be detected by a normal site. The browser will ask the server for file. That file is downloaded on the client's machine, and once it is downloaded, it will destroy the client machine. The next for observing the user's activity is spyware. Spyware, as its name suggests, collects data and records user activity. The first is keystroke logger. Keystroke logger would log all the keys pressed by the user. It can save your password, credit card number, whatever you type from your keypad can be stored. It can even have contact names and numbers. Hijackers, software that hijacks a program which is doing a different activity. Adware displays advertisements through pop-up window or in browser window. These advertisements are usually, as we discussed previously, to monitor the user's behavior. Adware can refurbish search engine results to find out which is the prime location for putting the advertisement on client's machine, where client clicks quite often, or replace other advertisement. Drive-by installation. It suggests tricking user into installation of the software, saying that this is a good book you can download, and when the user starts downloading, he has gone to some other site and he has downloaded the malware. To summarize this module, we talked about web threats. Web threats are the real threats because nobody is there who is not using web nowadays. We touched upon the client threats and server threats. We also touched upon how to mitigate this client and server threats. We also talked about the active code that is to be taken care of. The most one is cookie. Cookie is stored in a plain text which can reveal all the sensitive information. So try to store cookie in the encrypted form and try to save your machine from the attacker or malware.